Okay, so I'm back, hopefully with one last video for these extra problems. I've gotten myself a cup of tea and had a snack, so if you need a break, you go take one too. So continuing on here. Number 9 says, Priestley discovered oxygen when he decomposed mercury 2 oxide into oxygen and mercury. And it gives us the equation here. A says if 0.440 moles of mercury 2 oxide reacts, how many moles of oxygen will be produced? So I start with my 0.440 moles of mercury 2 oxide. And remember, the coefficients out front can stand for moles. So I have to go to my mole ratios here, and I know that 2 moles of mercury oxide will produce 1 mole of oxygen. And when I do that division, I end up with 0.220 moles of oxygen. For B, if 0.580 moles of mercury is produced, how many moles of oxygen are produced? So I start with my 0.580 moles of mercury. I look up to my equation for my mole ratio, and I have 2 moles of mercury to 1 mole of oxygen. And I end up with 0.290 moles of oxygen are produced. For C, how many grams of mercury 2 oxide must react to produce 3.75 moles of oxygen? Now with these ones, I just needed my mole ratio, just my meat here. Moles are meat, right? So I just needed my meat. So we're getting a little more complex here. So for C, I have 3.75 moles of oxygen, and I want to get to grams of mercury 2 oxide. Well, I'm in moles, so I can use a molar ratio, and I know that 1 mole of oxygen is produced from 2 moles of mercury 2 oxide. So from there, I can go to grams of mercury 2 oxide. So 1 mole HGO. Now I need a molar mass here, so I'm going to do that down here. So mercury from my periodic table has a molar mass of 200.59 grams, plus oxygen, which is 16.00 grams. So I do the addition and I get 216.59 grams, which goes on top here. When I do the multiplication across the top, I get 1,620 grams of mercury 2 oxide. Now, looking at this, I have an open face sandwich here. I have my meat, and I have 1 molar mass, which is my bread. So I call that an open face sandwich. Going to D. How many grams of mercury are produced when 14.7 grams of mercury oxide react? So 14.7 grams of mercury 2 oxide Now here I have to go to my molar mass sandwich because I start in grams, I want to end in grams. So I need my molar mass here. I calculated the molar mass of mercury 2 oxide up here, so I can use that. No need to do that again. Is 1 mole HGO. Now, I have my first piece of bread in my molar mass sandwich. I need my meat in the middle, which is my mole ratio. So I know that 2 from my equation up here, 2 moles HGO. Now I'm headed to mercury. Is to 2 moles of mercury right from there. But I want to be in grams of mercury. So 1 mole of mercury, now I can get this right off my periodic table because I did it right here, is 200.59 grams of mercury. When I go ahead and I multiply across the top and divide that by what's on the bottom, I get 13.61 grams of mercury. Moving on. Whoops. For E, I have to go close the door.
I'm ready.
Yeah, I see that. For E, the question is, how many grams of oxygen are produced when 6.20 grams of mercury 2 oxide react? So I start out with 6.20 grams HGO. I need the first part of my molar mass sandwich. So I need my bread here, my molar mass bread. So I have 16.6 grams HGO. That's 1 mole HGO. Now from here, I can go to my mole ratio, my meat. I put 1 mole of HGO on the bottom. There's a 2 in front of it in my equation. Oops, so actually I need a 2 there. Sorry about that. I'm going to oxygen. Oxygen has nothing out front, so that's a 1. So 1 mole of oxygen. But I am trying to get to mass of oxygen, so I can come down here and figure out my molar mass. That's 2 times 16, which is 32.00 grams of oxygen. So 1 mole of O2 is 32.00 grams of O2. And so I get a grand total of 0.458 grams of O2. Moving on to F. F says, how many grams of HGO must react to produce 2.30 grams of mercury? So I start with what I know, 2.30 grams of mercury. For my periodic table, I know that 200.6 grams of mercury are in 1 mole of mercury. I can then go to my meat, my mole ratio. which from my formula, there's a 2 in front of mercury. So 2 moles of mercury. I am headed towards HGO, so there's a 2 in front of that, so 2 moles HGO. And 1 mole HGO has a molar mass of 216.6 grams of HGO, and we calculated that earlier. So when I do my multiplication across the top, divide that by what I multiply across the bottom, I end up with 2.48 grams of HGO. Okay, moving on to 10. Problem 10 says, natural gas consists primarily of methane. When natural gas burns in a gas-burning appliance, methane reacts with oxygen to produce carbon dioxide and water. So we have this equation. CH4 plus 2O2 yields 2H2O plus CO2. So this will give us the ratios that we're working with. So for A, how many moles of CH4 must react to produce 13.7 moles of H2O? So I have 13.7 moles of H2O, and I'm headed towards methane. So I'm already in moles, so I can go right to my molar ratio. I have a 2 in front of my water, so that's 2 moles H2O. I have nothing in front of my methane, so that's 1 mole CH4. I'm headed to moles, so I'm there. I can just do my division, and I have 6.85 moles of CH4 methane. Going on to B. How many moles of carbon dioxide will be produced by the reaction of 8.31 moles of O2? So I start with my 8.31 moles of oxygen. I'm already in moles, so I can go right to my mole ratio. Oxygen has a 2 in front of it, so 2 moles of oxygen. I am headed to carbon dioxide, which has nothing in front of it, so 1 mole of carbon dioxide. And when I do my division here, I get 4.16 moles of carbon dioxide. For C, what mass of CH4 must react to produce 4 moles of H2O? Start out with my 4 moles of water. I'm headed to mass. So I'm in moles. I can go to my mole ratio. So it looks like I'm going to have an open face molar mass sandwich here. So 2 moles of water on the bottom. I am headed to methane, so 1 mole CH4, as I have up here. Now I want the mass of this, so I need to go with my molar mass, so 1 mole of CH4. Now I have to calculate the molar mass. So CH4 is, carbon is 12.01 grams plus 4 times my 1.008 grams. When I do the arithmetic, I end up with 6.0 0.04 grams of CH4. So that number goes up here. And just to double check, everything cancels out. So when I multiply across the top, divide that by what is on the bottom, I end up with 32.1 grams of CH4. For D, how many grams of CO2 are produced when 6 moles of CH4 react? So I start out with my 6 moles CH4, already in moles, so I can go right to my mole ratio. I have 1 mole of CH4 from my equation. I am headed to carbon dioxide up here, so 1 and 1. 1 mole of carbon dioxide. And I'm headed to mass of carbon dioxide, so 1 mole of carbon dioxide. All these are canceling out. Carbon dioxide has a molar mass of the C is 12.01 grams plus 2 times 16.00 grams. Do the arithmetic, I get 44.01 grams of carbon dioxide. So I plug that up here. Whoops. Multiply across the top because it's all ones on the bottom, and I get 264 grams of carbon dioxide. For E, how many grams of oxygen will be consumed by the combustion of 2.18 grams of CH4? So I start out with 2.18 grams of CH4. So I'm going to do a molar mass sandwich here because I'm going from grams to grams. Now CH4, yep, I have it right here. I have my molar mass here, so we have to get into moles. So I put 16.04 grams of CH4 on the bottom, which is 1 mole of CH4. Go to my mole ratio because I'm in moles now, and I see I have CH4 here. There's understood to be a 1 out front, and I am headed to oxygen, or I need oxygen here, so it has a 2 out front. Just double checking, make sure that's right. Yep. So I have 1 mole CH4 on the bottom to 2 moles of O2 on the top. That cancels. And I want the mass of oxygen. So I found my molar mass of oxygen somewhere else. I know that that's 32. So I can just use that because I found that in another problem. It's just 2 times 16. So it's 32.00 grams of oxygen. So when I go ahead and do that multiplication across the top and divide by what's on the bottom, I end up with 8.70 grams of oxygen. For F, I have how many grams of water are produced by the reaction of 139 grams of methane? So I have my 139 grams of methane. I need a molar mass sandwich here. I know that methane is 16.04 grams of methane per 1 mole of methane. I can go to my mole ratio now because I'm in moles. Methane has a 1 in front of it, so, well, actually nothing, but that's understood to be a 1. So 1 mole of methane. Now I am headed to water. And so water has a 2, so 1 to 2. So 2 moles of water. And I want the mass of water. So I know that 1 mole of water. Now I have not calculated the molar mass of this yet today. So 2 times 1.008 grams plus 16.00 grams. Remember, we get these numbers from our periodic table. Is 18.02 grams of water. Multiply and divide, and I get 312 grams of water. And last but not least, G here for this problem number 10. Oh, well, actually, I still have H2. What is the theoretical yield of carbon dioxide for the decomposition of 200 grams of CH4? So I start out with 200 grams of CH4. I need to get to moles, so we found earlier that there are 16.04 grams of methane in 1 mole of methane. I can now go to my mole ratio. If I go back up to my formula, 1 mole of methane, because there's nothing in front of the methane, so it's understood to be a 1. To carbon dioxide. Carbon dioxide has nothing in front, so 1 mole of carbon dioxide. 1 mole of carbon dioxide has a mass of 44.01 grams, which I found earlier. And so when I multiply across the top, divide by the bottom, I'm going to write that answer down here. I get 548.8 grams of carbon dioxide. Okay, and letter G. Or actually, I'm sorry, letter H. If the actual yield in the attempted decomposition of 200 grams of CH4 is 464.5 grams of methane, what is the percent yield? So for percent yield, remember, this is the actual yield over the theoretical yield times 100%. So they give me the actual is 464.5 grams. My theoretical that I just calculated is 548.8 grams. Multiply that by 100 and I get 84.64% is my percent yield. I'm going to stop the video here and do question number 11 on the last video.